Hi, today I'm going to explain how neurons communicate using something called an action potential. First, let's start with the resting state of a neuron, called the resting membrane potential. At rest, the neuron has a charge about negative 70 millivolts, meaning the inside is more negative than the outside. This is maintained by the sodium-potassium pump, which moves sodium out and potassium in. At this stage, the neuron is stable but ready to respond. Next is the receptive segment, which includes dendrites. This is where the neuron receives signals, and these signals create graded potentials, which are small changes in charge. They can be excitatory, making the neuron more positive, or inhibitory, making it more negative. If enough excitatory signals are received, the neurons reach the threshold about negative 55 millivolts at the initial segment. Once this happens, the neuron follows all or none law, meaning it either fires completely or not at all. Now we move to action potential. The first phase is depolarization, where sodium channels open and sodium rushes into the cell, making it more positive. Next is repolarization, where potassium leaves the cell and the charge goes back down. Finally, hyperpolarization occurs, where the neuron becomes slightly more negative before returning to normal. After this, the neuron goes through a refractory period. During the absolute refractory period, it cannot fire again at all. During the related refractory period, it can fire again, but only with a stronger signal. The signal travels down the axon in the conductive segment. Continuous conduction is slower and happens without myelin, while oscillatory conduction is faster and jumps between nodes and myelinated neurons. Finally, we reach the transmissive segment at the axon terminal. When the signal arrives, calcium channels open and the neurotransmitter are released into the synapse. One example is acetylcholine, which helps muscles contract. A disorder related to this process is multiple sclerosis. In this disease, the myelin sheath is damaged, which slows or blocks signals and can cause muscle weakness and coordination problems. In conclusion, the action potentials is how neurons send signals throughout the body, allowing us to move, think, and function. Thank you.